thank you. We really appreciate being welcomed to California. The Math Forum is thrilled always to be here. It's such a wonderful group. We feel a part of you by now. Certainly you've lent us a part of you, Suzanne. As many of you know, Suzanne Alejandre, who coordinates this, is a California native. But we lured her to the East Coast, and we're grateful. Thank you. So, as many of you know, I suspect, the format is that for 5 minutes there will be 20 slides that advance automatically. And the speaker has to try to coordinate, but they keep going regardless of whether they do or not. Now, from the participants' perspective, what you'll hear are things like, well, it'll either be thrilling and wonderful, or we'll crash and burn. That's it. So for them, it's like a NASCAR event, and they think that you're equally happy with either outcome. But I know that's not true. Right. I think, in fact, though, you realize that they are doing this for us, and we love them no matter how perfectly their coordination is. And so without further ado, let's start. The first person who's going to present tonight is my colleague, Annie Fetter. Many of you may know Annie for her Notice and Wonder Ignites. And she was part of the Math Forum before there was a Math Forum. That is, there was a research project called the Visual Geometry Project at Swarthmore, and one of the people who worked there was Nick Chakif, who wrote Geometer's Sketchpad. And they were classmates. And Annie has helped the Math Forum be what it is today, and we're grateful to have her speaking.
Okay, how's the sound? Sound good? Yeah. Way back? Everyone's good? Okay, first time using the mic here, so all right, we're ready to go. All right, here we go. So. A couple years ago, I was riding my bike to work one day listening to the NPR Environment podcast, and they did this thing about middle school math teachers going out on the Chesapeake Bay to learn sciencey stuff. And the leader of the group said, hey, does anyone know what kind of nest that is? And they said, it's an osprey nest. And he said, right, let's go. And I thought, how did you know? Wait, I want to know. And I thought, this happens in the math classroom all the time. People make decisions and we don't learn about it. So I looked at a bunch of notes from classroom observations, and I picked out opportunities where this happened, and I thought, let's organize them and have some conversation. Most common one, teacher asks a question, kid gives an answer, the teacher says, right, you're right. They have no clue whether the kid knows anything about why that's the answer. They had a 50-50 chance, for God's sakes, right? The second way that we hide decisions is we ask a question. When they get it wrong, then we ask them a question. I want to know, why the hell did they pick 6? I want to know that. I don't want to know if they know does 6 go into 3. That doesn't help me. It doesn't help them either. The other way is we talk about what we did without any why. So let's construct a rectangle. I'm going to do a segment, I'm going to do a perpendicular, then another perpendicular, and then I'm going to put a point on one of the perpendiculars just wherever, and then I'm going to draw another perpendicular, and then I'm going to make an intersection, I'm going to hide a bunch of stuff, I'm going to make it really pretty. Right? And you all agree that I've ended up with a rectangle, and you all agree, yeah, that all sounds big. I didn't say anything about why I did any of those things. What were the decisions behind them? I didn't tie the construction steps to the properties of a rectangle. It's just gone. Right? Here's another example. In what is considered a classic textbook, if you recognize it, you're probably fairly old. And, this is my grandmother's desk copy from 1967. So here's this problem, like you travel here and you come back, and how long did it take? Well, here's how you set it up. Right, we define this variable, and then this one, and then there are all these things that are important. Oh, and there's a cute picture, and then we make this table. And to the kids, that all makes sense because it's happening in front of them, but they don't know why those things were done. So when they're asked to do it, they don't know how to get started because we didn't make the decisions explicit. A favorite of mine, the kid comes up, slaps his stuff onto the document camera, and proceeds to read it to us. Right? I know what you did. I do not know why you did them. I want to hear why you did those things. If you have kids reading things at the document camera, shame on you. Here's a curriculum where here's another distance rate time problem. We want to answer something, so let's fill out a table. No, let's talk about where the table came from? Why did you decide on those columns? How did you decide to organize it that way? Why is that important? That's the important part, and that's the part that's getting hidden from the kids. Let's talk about x is greater than 5 and how to graph it in 5th grade. You just do these 3 things. Well, there's a lot of hidden stuff here. Why are we using a number line? Why does it go from 0 to 10? Why are some of the things open circles and some of them are closed circles? And then how come we only colored in some of them? And then what the hell's with the arrow on the end, right? All of this is hidden from kids. They just think these are the things you do, and if I memorize them, I'll be good to go. Right? So in a 1st grade class I worked in one day, so we're doing in-out tables, and the teacher says, well, the numbers going out are smaller than the numbers coming in. What does that tell us about the sign? And I said, no, don't ask them about the sign. Say, the numbers are this way, so what? And then I thought, I'm still pointing out about the numbers. Let the kids figure that out. It's important that you would look at the numbers and see how they work. In a 10th grade warm-up, geometric probability, what are the odds of hitting the bullseye? Before the teacher even asked a question, she wrote this on the board. I think it's important that some kid come up with, why would we start like that? That's really important. She made a decision and didn't talk about it. In the same class, she asked, well, how many ways can we arrange 4 things? And some kid says, oh, there are 4 slots. And so she proceeds to write this on the board. That's not 4 slots, that's 4 very particular slots for something, and no one talked about why. In the same classroom, put this in your calculator, they finally figured out we needed it in y equals form. Some kid says divide, and the teacher asked to divide both sides by what? I'm like, the kid didn't say anything about both sides. You're making these decisions for them. Let them do the thinking. So, we have this standard for mathematical practice that's about constructing viable arguments and critiquing the reasoning of others. If we never hear that reasoning, how can we critique it? Right? We need to make sure that that is more important in our classrooms than the answers. So what do? Don't ever say right when a kid gives an answer. Please, please, please. Ask them, how did you know? How did you decide? Make sure what is always accompanied by why. Let the students make as many decisions as possible. Do not state the obvious because it may not be obvious to everybody else in the room. Right? Pay attention. Look for decisions you make your kids could make instead. Notice moments when the kids don't say why and you didn't ask them. Try a couple more times a period to ask them to do why and be conscious of explaining your own decisions. Let's practice. I constructed the perpendicular because a rectangle has right angles. The answer is 6. How do you know? Very good. All right.
Thank you, Annie. That little bit about the bike, I don't know if you know many folks who are from the far northeast, like Vermont. Annie comes from such a place, and she rides her bike in the Philadelphia area in all kinds of weather to the office and carries the equipment on the back of the bike to the office. And I think you can get a sense she's probably a pretty tough cookie when it comes to all things educational. So our next speaker is apparently someone that some of you know, Harold Pistorius. I understand that he has an entourage. Is that true? I don't know if everybody knows that he was the director of the Center for the Mathematics Excellence and Equity at Lawrence Hall of Science in Berkeley. And in the late 90s, helped develop performance standards and assessments for the New Standards Project. Currently helps teachers develop students' mathematical identity and the academic language of mathematical reasoning. Did you know that he loves to dance and party? Did you know that he's delivered a lot of babies? Something to find out more about.
You can deliver my baby.
Sound good. I just see the warning.
Warning.
So obviously, I only can talk about what I know. So academic language is something that we have to be very deliberate and helping students learn about it and think about how is it that they are using it to communicate their mathematical ideas. And you know, it's not anyone's primary language. I haven't met anybody that says my first language is academic. right? So we all have to develop it. We have to help students understand how is it that they are going to develop it and use it. And also, academic language doesn't work well in everyday situations. I always get in trouble when I say I took my hypotenuse to the movies. But developing the academic language is essential to develop an understanding of the content, particularly for those everyday situations where we might need to know what the speed limit is. The texts, in academic texts, it's a complex text that students need to get access to, and logic, analogy, explanatory narrative are part of what makes academic text complex, and we need to help them get that. Graphs or some representations are the same no matter the language. The DNA, we will always see it as a double helix, like that one, because no matter the language, the representation that's very similar. The same way, when we think about graphs and y equals kx, it's going to be a straight line no matter what language mathematics is being done. So we need to help students understand how these academic language crosses language boundaries. And that we have to help them develop the proficiencies or competencies that are necessary to get to a level of almost native-like use of language. And some of those, so I want to talk to you about some of those competencies. The first one is phonological. That's about sounds. And you know, for many of us, and I don't know if you can tell, but I'm an English learner myself, so for some of us, those sounds are very hard to understand. Here are some examples. Tens and tenths, 60 and 16, but it makes a difference if the problem is about tens or tenths, right? And when we're learning about fractions, the whole piece, it's very confusing, particularly for beginners learners of English. The next competence is about lexical, it's about words. There are many words, and particularly we have to help students understand that there are some words that are very technical, that the technical of the content, and then words that change meaning. Can you spot any words there that have more than one meaning? Say them out loud. You have 5 seconds.
Similar.
So we need
Rotation. Dilation.
the other very small words like or, coffee or tea, coming or going. Was that your boyfriend or your husband? Or is exclusive when we use it in everyday language, but in mathematics, it's inclusive. A or B is true, or A, B is true. The other one is for is. That's another example. See the 3 sentences at the top. The word is the same 2 letters, but when we write them in mathematical notation, then we have to use different ways of doing that. The next competence is grammatical. And it makes a difference if we understand the way in which we put the word. And you know, if we talk about base and square, it will be different if we talk about area or number, right? So we need to help students understand that what the context is, and when we're talking about it, how it changes. Prepositions is another issue. The temperature fell to 10 degrees by 10 degrees, from 10 degrees, or just the temperature fell 10 degrees is different, just by the small words and how where we put them. So we need to avoid some pitfalls. For example, when we ask what's the difference between 11 and 6, and the student says 6 is curvy, 11 is straight. If we want to ask them to compute 11 minus 6, we have to be careful about how we ask that. Another one is if we ask them to take 7 for 93 as many times as we can, and they say again 86 every time. So we have to avoid those pitfalls and conversations that are hard to understand, like this one.
You can't lie. Where is Shrek?
I don't know where he's at.
You don't know where Shrek is?
On the contrary.
So you do know where he is?
Possibly in Florida last night. I definitely rejected the idea. Honestly, I do or do not know where he should probably be. He wasn't where he is.
Thank you.
Thank you, Harold. That's an interesting person, delivering babies and complexity with language and deep insight. That's very nice.
That's it, thanks.
Our next speaker will be Mary Reynolds. Mary was a 6th grade teacher in Petaluma and Rohnert Park. She's in her 2nd year of principalship at Olivet Elementary. She loves professional sports, and she's a huge fan of the Oakland Raiders. And she's confident that the Raiders will win the Super Bowl at Santa Clara this year.
Maybe not after last weekend.
She loves Twitter and blogging and says she has a PhD in hashtags. Welcome, Mary.
Okay, so my story starts 2 or 3 years ago. I was reading a story. It was the Eloise Ready to Read trilogy. Eloise in the 1970s was a smoker. She used to smoke chalk for fun. So it's a little controversial. She's a spoiled brat. She lives in some hotel in New York City on the tippy top floor. There was a movie. So Eloise was kind of interesting to me as I'm reading this story. And it turns out I have my own Eloise. As you can see in the picture, they are on any given day spoiled brats together. So we're reading the story, and the story's progressing, and Eloise is having a math lesson with her private tutor, whose name is Philip. It was very interesting, because then I was reading about math, I was excited about it. So Philip is asking Eloise, Eloise, what is 6 plus 5? Eloise is mocking him. She's saying, Philip, what is 6 plus 5? Ugh. And so the story goes on, and finally Eloise says, 5 plus 6 is the same as 6 plus 5. I'm like, holy hell. Eloise has demonstrated the commutative property of addition. This is amazing. My daughter, on the other hand, who was 3 or 4 at the time, was less than thrilled. But I'm like, this is wonderful. The commutative property of addition is demonstrated in some little book by like a kindergartner. This is amazing. This is great. And then things took a turn for the worse, because the next page was Philip's reaction, and he literally says, oh, Eloise, and he's so disappointed and distraught and upset, and I'm like, what the hell is Philip's problem? Like, let's get a new tutor. Philip literally hangs his head in his hands, and I'm like, God, he really is smarmy. This is annoying. So then I got worried. I got worried about the world outside of my classroom. I got worried about the world in general. So the next thing I decided to do was Google, which you should never do when you're worried. But I Googled it anyways, like Americans and math, and these 2 images came up. And I was just like, oh, this is worse than I could have ever imagined. This is so bad. And so then I started thinking automatically, like, what can you do to make things better, personally? Like, what can you do? So I immediately thought of the Standards for Mathematical Practice, one of my favorite things in the world. And then I started to think about how to rewrite the ending to that Eloise story. And so this is my ending, and I would have said, this is wonderful, this is great, you've demonstrated the commutative property of addition at a very young age, and now you'll probably be successful in algebra and beyond. Eloise, this is wonderful. At this point, my daughter was like, I want a new mom. Can I request that? And I'm like, no, that's not going to happen. And I really see the power in SMP3, construct a valuable argument, critique the reasoning of others. The verbs of that practice are particularly powerful because when we can engage with each other, parents, teachers, students, administration, about standards for mathematical practice and construct valuable arguments and critique the reasoning of others in math, it's exciting. So my challenge to you is to rewrite the ending of your own math story in the work that you do every day with students, parents, teachers, but especially students. This is what it looks like when Camille, who is my daughter, and I engage in SMP number 3. I also told my hairdresser, you better make my hair look exactly like that today. And it's a lively conversation, and it's a lively conversation that I have with my colleagues. And what my colleagues are telling me is that they've seen a shift recently in getting the answer out of the way. Earlier it was like, what is the answer? That's all we care about. And now it is like a focus on student ideas, academic discourse between students. My teachers and staff say they really like opportunities to actually do math and engage in math, and have multiple conversations about more than one answer or the same answer. And then that made me think about relationships. And relationships on lots of different levels. And what is the relationship between learning, engagement, and discourse? And then, after the whole entire speech, before I did all the slides, I said, oh, you need to Google how to do one. So Google said for Ignite, just do 3 things. Talk about 3 things, and those are my 3 things I love in no particular order. And you can tweet me, you can email me, you can ask me why I blog at betterknowacupcake.com. And if you ever want to read something and be like, why is that? What? Weird. She's actually typing that. Read the blog. Thank you so much.
Thank you, Mary. You know, I said that there was terror up here in this group, and I think maybe we could substitute productive terror for productive struggle based on the quality of what we're getting here. The next speaker is Chris Shore, math coach in Temecula, California, and editor and author of the Math Projects Journal. Apparently, Chris once turned down a job for twice his salary to continue teaching. Didn't we all do that? And he met his wife by catching the garter at his brother's wedding after she caught the bouquet. And 6 months later, they were engaged. Chris.
Good evening, my genetically coded math experts. I'm here to share with you why I just called you that, and why I use that as the pet name to greet all of my students in class every day. I'm going to give you the same annual speech that they get from me, but you also get the bonus of the backstory of where it came from. Started with a student a long time ago that, let's say, was less than actively engaged in class, and I caught him trying to eat Skittles. So I asked him to put him away, and he tried to sneak some more. So I took the Skittles and dropped them in the wastebasket, from which erupted this cloud of color. And it was quite entertaining to the class, but it was visibly disturbing to the student. It was more of a reaction I was looking for. So I took him outside and kind of smoothed things over. And almost in tears, he confided to me that the reason he wasn't participating in my class was the fact that his family did not give him the math gene. He said his dad didn't give it to him, his uncle didn't give it to him, and his grandfather didn't give it to him. Why it was the men in the family who were taking the rap, I don't know, but there they stood, shouldering the blame. So this put me on a campaign. Actually, it was more like a rampage to convince every one of my students that they were born to be mathematicians, that this is encoded in every cell of all of our bodies. So every year now, I'm given the speech that we have 5 things that we're genetically coded to do better than any other creature on the planet. The first 3, you guys mastered before you got to me. The 4th one, we will spend the entire year developing you in this class, and the 5th one, you spend the rest of your life trying to figure out. The students very quickly realized that those first 3 are to walk, talk, and read and write. That while the apes may stand on 2 legs, they prefer to walk on all 4s. Yes, birds chirp, but they don't communicate in the level of language complexity that we humans do. And yes, a dog might pee on a bush to mark its territory, but it cannot urinate the words "no trespassing." We have the ability of these things because it is in our DNA to do so. And so is the ability to do mathematics. We have this ability to ponder the workings of our universe and create conventions to represent them, but I must concede to you that there are still some animals on the planet that do math better than I do, and the bees are one of them. Do you know when they build their honeycombs, they make perfectly regular hexagons? All the sides are congruent, and every one of those angles is 120 degrees. And yet, after nearly 3 decades of drawing geometric figures on the board, I cannot reach that level of precision. But I can ask a question. Why hexagons? Why don't the bees express their inner artist and every once in a while pick another shape? It has to do with mathematics. It starts with the tessellations, that these shapes must tile without leaving any gaps. They also must be regular and congruent, because those really anal bees insist on doing the same thing over and over and over again. Even with these limitations, that offers 3 options. So I ask again, Why hexagons? For that, we need to go a little deeper to the isoperimetric principle, which states that for any given perimeter, the circle yields the largest area. So of our 3 finalists, the bees choose the hexagon. And for that reason, we have to get really up close and personal with the bees and see that they actually excrete the wax from their bodies to create these honeycombs. So I put it to you, if you had to squirt out of your tail end the materials it took to build your house, would you want the most bang for your buck? So with all that mathematical prowess going into these hexagons, how do I still claim genetic superiority in mathematics? It's because the bees do not understand the why behind what they're doing, and I do. And if you've been able to follow this stream of mathematical consciousness that I just took you through, then you do too, and you've proven my point that every student in our class can indeed learn mathematics because they have the DNA to do it, and the bees do not. Which leads me to our 5th, that we are genetically coded to know that definitely someday we will die. And therefore we contemplate the meaning of life. The cat thinks as long as it stays away from the dog, it lives forever. We know that's not true, so we wonder why we're here and why we were given these amazing gifts. So I dedicate my talk to Brian Gregory, the student that started it all, that unfortunately died 3 weeks before he would have graduated high school. But he doesn't want you to remember him as such. He wants you to remember him as the ill-confident freshman that became a senior, who completed all the math requirements to get into college, got accepted, and intended to major in oceanography, a STEM field. He wants you to remember him as the poster child of growth mindset before it was ever a catchphrase. So in his memory and to his honor, I encourage and challenge you with the faith that they can learn it and that we can teach it to them. Share the mysteries of our planet with our amazingly gifted and genetically coded math experts.
Poignant, funny, insightful, amazing. Next speaker, Suzie Hawkinson, president of TOTOS, Mathematics for All, formerly the executive director of the California Mathematics Project, formerly the director and co-director of the UCLA Mathematics Project, formerly project evaluator for teacher quality grants, Eisenhower grants, and NSF grants. I think she was probably formerly in charge of everything. High school mathematics teacher who walks 2.5 miles on average a day.
Have you ever wondered how you or your friends are placed in specific classes in school? Was it teacher recommendation, test results, student records, skin color, counselor decision? Many years ago, when there were mid-year graduations, Carol and one of her friends began junior high and 7th grade in the same cohort of 4 classes. All of their friends were in the other cohort of 4 classes. At the end of the first week, Carol and her friend took a mathematics skills test and scored 100%. As a result, they were moved to the other cohort of classes. Of course, they were glad to join their friends. When Carol went to sewing class with this new cohort, she noticed that the students in the new cohort were also making a gym bag, but they were several steps ahead. She had to catch up. Carol didn't know at the time, but she had been placed initially in the lower level cohort. She moved to the other cohort because there were too many students in her cohort and because of her accurate mathematics skills. In 8th grade, she asked her mother to sign a form so that she could take algebra in the 9th grade because she knew she could excel in mathematics. There was no 8th grade algebra at that time. By 9th grade, there were no cohorts. Carol was enrolled in a lower level science class, although she wasn't aware of it. She wasn't required to enter the science fair, whereas the other class was, so she was glad to be in her class. Carol was told by her parents to do her absolute best, follow rules, and not question the status quo. She only advocated for herself when it came to mathematics. In other courses, she just let the counselors place her in classes. What evidence was used to place Carol in the lowest level cohort in 7th grade? What were the expectations of the teachers, knowing that this was the lower level cohort? Did they assume that students could handle higher expectations? Should teachers expect less of students if their scores are not as high, or if their teachers did not recommend them? How might teachers provide greater opportunities, encouragement, and scaffolding to enhance and enrich the learning of students who are underserved? In the 3-year high school, Carol took all of the advanced mathematics courses offered. That was before the school had honors courses or AP courses. The students in high school had to take the Iowa test in 9 subject areas. Carol scored over 95 percentile in mathematics, 70 in a couple of others, but 50 or lower in everything else, ending with a composite score of 55 percentile. She was invited treasurer, was in leadership class the last semester. Her teacher heard she was taking math analysis, the highest mathematics course at the school, and asked her, "Why aren't you in my physics class?" The counselor did not place Carol into chemistry until the 2nd semester of her junior year, so she couldn't take physics. Another student said the counselor insisted that she take chemistry at the beginning of her junior year. How predictive are standardized test scores? What evidence did the counselor use to encourage or discourage students to enroll in cognitively demanding classes? How can we encourage counselors to set high expectations for all students? Don't put students in boxes. Don't assume students can't when they can with support. Don't let test scores, skin color, counselor, or teacher recommendations determine what a student can or cannot do. Do encourage students to take high cognitive demand classes. Do let students know they can achieve and that you believe in them. Do provide support when needed, enhance and enrich the learning of all students. If you believe you can't, you won't. If you believe you can, you will put in all of your effort to accomplish it. Carol has promoted this philosophy and equity and excellence to others, students, friends, family, and colleagues. In junior high, Carol placed 2nd in the school sewing competition and received a 7th place in American Legion Awards, an honor recommended by teachers. She graduated in the top 10% of her high school class. Carol has a BA and MA in mathematics and a PhD in education. She is the person giving this Ignite tone. Promote equity and excellence, eliminate bias, set high expectations, be an advocate.
Next up, David Rosenthal. David comes from Oakland. He's a teacher on special assignment in the Rise Community School in Oakland.
Oakland Unified School District.
Married to another teacher, father of 2 daughters, who are not teachers, and a published poet. The book is The Wild Geography of Misplaced Things. David.
So, you can hear me. Some time ago, I was talking to a layperson, civilian, a non-teacher. And they said, "So, what's your opinion of the Common Core?" It's kind of a loaded question these days. So I talked about practice standards. I talked about the math standards, but also the practice standards for ELA and next generation science standards. And he thought those sounded like pretty good ideas and kind of interesting. But he also thought they were kind of highfalutin and said, "Those sound like the habits of mind of genius. Do we really expect every student to be an Einstein or a Shakespeare?" And that made me think of one of my favorite quotes of all time. This is the first part of that quote coming up right here. It's from John Taylor Gatto, who was a New York City Teacher of the Year 3 times and a New York State Teacher of the Year, and taught for 30 years and a long time. And at the end of his career came to the conclusion that genius is as common as dirt. This is a conclusion that I've also reached, and it's a assertion that I hold very strongly. He wrote this in an essay called Against School, which is a critique of the American public education system as this kind of warehouse to produce drones for the system by crushing that genius. He says schools numb creativity, normalize boredom, coerce compliance and conformity, create dependence on external validation, and create this sort of network of mutual surveillance. These are critiques of the system that I actually have sympathy with. I think our system does a lot of these things. One thing I don't agree with that Gatto came up with was his solution to this, which was homeschooling, which he sees as this sort of libertarian escape from this controlling institution. I have a lot of problems with the idea of homeschooling, not the least of which is that I think it exacerbates a lot of the sort of social inequities that we're trying to ameliorate, a lot of us in our work. After all, households have wider variance in access to resources and experiences than even school sites have. So it would just widen a lot of those gaps and problems. But I think if we're going to attack problems like social inequality, we can't ignore the critiques that Gatto made of the system. And one thing that worries me a lot is that we focus so much on certain outcomes and norms that nothing new can come into the system, and it can't really be transformative. We talk about college and career readiness, but when I look around the world and think about the state things are in right now, I really have to question the viability of the post-secondary options that we're corralling students into. And it makes me think that, you know, our best hope, maybe our only hope, is that the students we're working with will come up with new ways of learning, new ways of living, new ways of organizing society that you and I have not yet even imagined. The good news is they're up to the task. It turns out that humans are wired to learn. And that means the youngest students entering our system have that wiring intact. And our job is really to let them be and to protect that so it doesn't get crushed by the system. So for the rest of this presentation, I'm going to recite to you a poem I wrote a while back about these ideas and let you see pictures of 4- and 5-year-olds doing what humans are wired to do. The poem is called Genius. Genius is as common as dirt. It comes before us every day. Little Shakespeares conjuring worlds with words that we no longer say as forcefully or carelessly as they do. Playing on the yard, digging in the concrete cracks, they find the pebble or the shard that only their intent makes rare, the way distraction makes them free. And if their will to play could mend our broken will to let them be, we wouldn't have them stand in lines again, or sit in squares with crisscrossed legs on checkered rugs, or turn their searching eyes to stares. The system that Gatto described that threatens to numb the genius that these students come into our system with, it also threatens us. It threatens to break our will to let them be. And we have to fight against that. And the best way we can fight against that is to take strength in their will to play, and their will to learn, and their will to grow. To truly transform the system we work in so that it can transform society would take an inordinate amount of genius. But the good news is, genius is a resource that is all around us every day. Thank you.
Very nice. Next speaker, Elizabeth Statmore. Went to Princeton with Stephen Strogatz. The Joy of X. Look it up. This is part of who Elizabeth is. She likes to knit platonic solids. She can knit a small stellated dodecahedron in about a week. She was once fired by Steve Jobs 3 times in one day. And teaches pre-calculus and geometry at Lowell High School in San Francisco and contributes radio commentaries for KQED-FM. She's a language and logic nerd, yes, and did her PhD in comparative literature at Stanford. Elizabeth.
So once upon a time, there was a locksmith. Can you hear me? Mic check.
Have Annie help.
Annie. Where are you? Okay. I'm afraid to put that in my box. It's off? Oh.
Off is a problem. Can we stick on the table? Is that better?
Once upon a time, there was a locksmith who was unjustly accused and convicted of terrible, terrible crimes. He was thrown into the deepest, darkest secret prison at the back of beyond, and he was left there to rot in an isolation cell. After a while, his wife on the outside, who loved him very much, went before the king and begged to be allowed to give him a prayer rug so he could observe his prostrations. The king considered this a lawful request, and so she was allowed to bring him the rug that she had made. The prisoner was so grateful to get this rug that he gladly accepted and performed his prostrations in his prison cell. And as he did so, day after day, he began to notice that the secret to solving all of his problems was right in front of his nose. One morning, as he kneeled down, he realized that his wife had woven into the prayer rug the exact pattern of the lock that imprisoned him. And so all of a sudden he understood that if he could just persuade his guards to see that they were trapped in prison too, they could work together and they would have everything they needed to escape. So he spoke to his jailers and they saw that they were in prison too. So they formulated a plan. They would bring him scrap metal and he would make beautiful, useful objects that they could sell in the marketplace so they could accumulate what they needed for their journey. The proceeds would cover their food and supply costs, and they pooled their resources and skills, and then they were able to leave the prison. And if they could bring him the strongest piece of metal they could find, then he could fashion a key, and that would open the lock to the prison that was keeping them all in bondage. So one night, after everything had been prepared, the locksmith and his jailers unlocked the prison and walked out into the cool evening air. They knew they had a long journey ahead of them, but they were so excited to be outside, to be free, that they started to notice all these patterns and symmetry in mathematics, and they became genuinely curious. They left behind the prayer rug so that other prisoners might learn how to make their own escape too. It did take them several days, but eventually they arrived in the locksmith's home village, where he was reunited with his loving wife and their beautiful flock of unicorns. His former guards became his friends, and his neighbors and his colleagues, and everyone lived together in peace and harmony and a creative sense of mathematical discovery and flow. So, with their new freedom, they were able to start expanding their attention and focusing on solving other world problems that were far more important and pressing, and they could do so for the benefit of all sentient beings. So I've been a meditation teacher for a lot longer than I've been a math teacher, and I really love this story because I think it shows us the whole process of achieving freedom from the psychological prison that we know as a fixed mindset. A fixed mindset is what we call in psychology an introject. It's a momentary identification or an over-identification with those internalized negative beliefs about ourselves that cast a spell over us. And they make us believe that we really are in this prison. But an identification is just a momentary defense mechanism. And noticing that you're having it is enough to free yourself from its spell. So this is what we can do to help our students wake up from this enchantment. It doesn't work to tell a student to have a growth mindset, because that is using a fixed mindset to cultivate a growth mindset, and telling is not teaching. To truly teach a growth mindset, we have to invite students to notice their own inner fixed mindset moments, which are just like weather systems that are happening inside them. We can help them by reminding them that this is just a moment of temporary insanity. And that catching it in the act and noticing what's actually going on inside themselves is enough to help them achieve freedom. But you can't dislodge one thing from the psyche without replacing it with something better. And that something better is awareness and noticing. And my great teacher, Fred Orr, taught me, and I use it in all my teaching, that noticing shifts the energy. And in fact, it's the only technique that really works. So we have to teach students how to notice their own fixed mindset and to refrain from acting on it. Notice and refrain. Notice and don't react. Notice and don't react. And before long, they'll begin to realize that they, in fact, are brilliant too. And that by noticing their fixed mindset moments, we can help them to escape from the prison of identification with their own limiting beliefs.
I sense a theme breaking out of our mutually constituted prisons: creativity. Next speaker, John Malstead from the East Bay. John is the 6th generation of Johns in his family. Apparently once set a Guinness World Record for the most high fives in 1 minute. And plans on getting it back again this spring. Maybe afterwards we can all give him practice. His son missed being born on Pi Day by 4 hours. He was difficult from the start.
It's true. Oh, this does work. Lots of people. What the? I want to convince you in the next 5 minutes to make your students think this in your math classrooms. But I know what you're thinking. What F word is he talking about? Because there's 2 dirty F words. One is, and the other. As far as I'm concerned, this is the dirty 4-letter F word in math class. I actually tell my students I'd rather they say the other one than this one, and sometimes they take me up on it, which is always interesting. But what do we know? We know kids are born with this natural curiosity for the world around them. They love exploring things. They love seeing how they work and discovering. I guarantee my son thinks, what the at least daily. And this curiosity continues into the math classroom, at least at first. Kids think, I can count things, I can pattern. Oh my God, this is so cool. And then somewhere along the lines, we beat that curiosity out of them until we get classrooms that look like this. So what do we do to bring some of that curiosity back into the classroom? We have to show students things that surprise them, things that are counterintuitive or unexpected. In short, things that make them think, WTF. Things like this. Every week, the first week of school every year, I write this on the board, and I ask, what is this?
5.
Okay, what is 5? Show me 5. Okay, so that's 5. Well, no, that means 5. Okay, so what is 5? And then down the rabbit hole we go as students talk about what numbers are, whether math was invented or discovered. And pretty soon I have a classroom full of 8th graders complaining how much their heads hurt because they've realized they have no idea how to define a number or where they came from. They're just these magical things that have appeared and we don't know where they came from. Here's another fun one. We might have some elementary teachers in here with their own curious moment right now, like, why did you put an exclamation point in a math problem? And my students think the same thing. They think I'm just saying 0 very excitedly, like 0! Because what? But I explained factorials to them, and so we talk about 3 factorial, 3 times 2 times 1 is 6. And so what's 0 factorial? Well, it's gotta be 0. It has to be 0. It can't be anything but 0, right? 1? What the? How does that work? And at that moment right there, you've got it. They need to know how this works. Can you imagine teaching every day in a classroom with kids who needed to know how the math you're teaching them works? Are you kidding me? 0 to the 0 power. They know that anything to the 0 power is equal to 1, right? But does 0 hold that rule? No, it can't, right? they want to know what the calculator would say. So I say, great, let's graph it. And so we do. And I show them this. And then I watch as one by one their little adolescent heads explode. This doesn't make any sense. And again, their minds are mine. They have fallen right into my trap. Or these calculators. These are all pictures of the exact same calculator. And there comes that look on their faces. They're thinking, what the is going on here? They need to know how this works, and they're so curious. All they care about is figuring out what's going on here. Infinite series are another fun one. Students think that since they don't end, it must sum to infinity or there is no solution, right? But I tell them, no, it sums to 1. And they think, seriously, again with the 1? Like, what's up with the 1? But I say, I'll prove it to you, and I put this up. And then just like dominoes, I see their faces change from really confused to, I get it. That curiosity has been satisfied. I didn't have to say a word. It's amazing. And this by far is my all-time favorite infinite series. If you've never seen this or seen the number file video about this, take a second and think about what this series sums to. I have time. I can wait. Don't worry. -112? What the f? This is one of those mic drop moments in math class where you just drop the mic, you show them, and you watch as they lose their freaking minds over this result. It makes no sense, and it's amazing. So, I encourage you to use these problems in your math classrooms. You can use them as warm-ups or time to your grade level standards. I give them and I let them propose some answers and then split the room based on what they think the answer is, and then we debate. We talk about, we argue. This side argues for them, they argue against that side, they change their mind, they change sides. It is an SMP number 3 gold mine. I have students who come back from high school and say that they miss the most about my class is debating these types of surprising problems. And speaking of high school, if you do teach high school, especially seniors, I'd encourage you to put this on the board towards the end of the year, and they're gonna get that confused look on their face at first, and let them think for a minute and then tell them, this is what happens after you graduate. Shit gets real. Thank you.
I think I'm ready to go back to school in John's classroom. Next speaker, Rebecca Lewis. I think you may know her. She's been educating students and teachers for 19 years as a K-8 professional development provider in mathematics at the Shasta County Office of Education. Currently serving as project director for a California Math and Science Partnership STEM grant, working with K-2 teachers. She and her husband live in Reading with their 2 boys, 13 and 10, where they are constantly running around baseball diamonds, up and down basketball courts, and gaining yards on football fields. She served on the CMC North board for at least for the last 6 years, and very enthusiastic about her upcoming presidency. Her nickname since kindergarten is Bag Lady, and apparently she's maximized its contribution to her career development.
Does anybody have a bag I can borrow? I think you all got one. All right. Well, if I could click my heels 3 times right now, I think that I might want to just kind of step off of here. Oops. I'm sorry, Suzanne. But I do. I muted it down a little bit. I gotta start over. I just did the volume a little bit down.
Okay. So volume is.
Yes.
Okay. So you want it
That's
halfway?
perfect.
Okay. So we're starting you over.
Take 2. Exactly.
Do I trust you? And then you put your hands.
All right. See, I really want to click my heels 3 times now, just like Dorothy, and go home. But I'm not going to, because I want to talk to you about CMC and all the wonderful things that I am so passionate about. Who here is a CMC member? So as we think about CMC, it is what's amazing. I want you to look to your left, I want you to look to your right, I want you to look in front of you, and I want you to look behind you, because this is an amazing organization that you are part of. It's an association of people who appreciate the beauty and fascination of mathematics. So before you got here Friday, you were probably sitting wherever you are in your classroom or at your job and thinking, I want to go and go someplace where I can think about where I'm going to take something away and solve all the woes of mathematics. So you came to Asilomar, where you're going to take away some ideas. And here you are thinking this might be Oz, the Emerald City. And it's this idyllic place, the Pacific Ocean. The weather is absolutely amazing this weekend. It's fantastic. And so here we are to get new ideas. Our conferences are fantastic. We come for the speakers. We come for the people. And we want to know who inspires you. So it might be a great idea, intellectual idea, an idea for your classroom, much like the scarecrow. Or it might be an idea, something from your heart like the Tin Man that inspires you. Or it could be something where you're getting a new idea, and much like the lion, where you're getting the courage to use it back in your workplace. So we have this blend of the scarecrow, the Tin Man, and the lion to really help us back in our classrooms. But it's not just the speakers. It's the network of people that we have all around us here that really inspire us. It's my board, and it's Kathy Carroll and Hope Berkey who have asked me to be here and inspired me along the way, believe in me. I can't do enough with those two people. But we have obstacles, don't we? Common Core implementation has been a breeze for all of us. Nobody has had any difficulty. SBAC, I mean, awesome all the time, right? So we have these challenges, and it might not just be those systems. It might also be some things that obstacles. It might be money. It might be some other things in our districts. Whatever the Wicked Witch of the West is, or the Flying Monkeys are for you, CMC is an organization who can empower you to help you find some of those resources. We're advocates, and that's what your CMC membership does for you. So we're going to follow that yellow brick road together, and each brick on that road is a little bit different for each of us. So along that path, we're going to be able to use our membership to help us. Those people that you looked at, that's part of your membership. Your board members representing you at the table to advocate for things that you don't even know about, but if you read some of your literature, you know. But we're going to look at some of the things that CMC really has to offer and review to make sure you're getting the most of your membership. So as you look up here, there's a map of the CMC North affiliates. What affiliate are you part of? And if you're not, why not? Join an affiliate, be active, stay involved, continue professional growth along the way, and really be part of it, because that's really part of the big connection of CMC. And the Munchkins, the support for the students. There's definitely the math festivals that we have, student activity trust funds. Those are opportunities in your CMC membership. We want you to be having those people come out, or you apply for those funds. There's free resources. We have the Early Learning Math at Home and the Math at Home books that you can download, these articles that you can use. The website has all sorts of information, the speaker handouts that you maybe didn't get to all the sessions. Make sure you're using some of those free resources on the website. And the Communicator, one of my favorite journals. I can't wait for that to come quarterly and read the amazing ideas, activities you can use right away in your classroom or share with colleagues, information about what CMC is advocating for. And also, we have awards. We had our Presidential Award winners. We had our Beagle Award winner. We also have scholarships. We have grants that are available. You know all the things that CMC supports and can support you with. We want you to take advantage of it. And if you haven't read page 43 in your program, please do. Because CMC costs $50 to join, and a $500 grant is available twice a year. Now, it's a room full of math teachers. I think we can figure out that's a pretty good return on our money, so let's start using it. I'm not sure what your pair of ruby slippers is for you, but I'm positive that CMC can be that thing to get you where you're going, or at least help you. So I want you to think, are you using CMC? Are you letting CMC work for you and finding something that's a pair of ruby slippers? And if it isn't what Dorothy wanted to get home, and you might too, but I encourage you to go to the home page at least and explore www.cmc-math.org and find some of the amazing things home there that you can really make your home base. And so as we think about this amazing city of Oz and the Emerald City that CMC can be, I want to remind you that CMC believes that all students have the capacity to become mathematically competent and confident. And I want to thank you for being CMC and making that happen.
Wow, are you in good hands? Nice future for this organization. And last but not least, Max Ray. You may know Max as the math educator who believes that 2 is greater than 4. He's been involved with the Math Forum since writing Ask Dr. Math when he was in high school. Can't believe I've been working that long for this organization. He has written the book, Powerful Problem-Solving Activities for Sense-Making with the Mathematical Practices. I know he's inspired many of you. Imagine getting to work with Max every day. Max Ray.
When I first started telling people I was on Twitter, I think they assumed I was a Justin Bieber fanboy. But we've learned a lot about why tweeting matters. So I'm going to tell you today why I tweet. And for me, it's because it's the best faculty lounge in existence. All of the great thinking, none of the negativity. What Twitter is it's like a news feed, but just of the news you care about from the people you follow. So it's like if the CNN ticker was about math education all the time, every day, and what people were sharing were their amazing lesson ideas, like this one from Graham Fletcher. And even better, Twitter has become the place where people share their students' thinking, because it's so easy with our smartphones in our pockets to just take a picture and put it out there and engage in a conversation about real student thinking in real time. The other reason I tweet is because even though it's 140 characters, it's part of a long-form conversation. So when I blog, which I will again soon, I'll tweet the blog post and then we can have conversations. It's a little easier than going on and commenting. You don't have to write as much. It's just 140 characters. So when I first got on Twitter, this slide was a lot shorter. But since then, elementary teachers, middle school teachers, high school teachers, new teachers, and experienced teachers, teachers from all over the world, coaches, researchers, math educators, they're all on Twitter having the same conversations. A high school teacher tweeted about a problem that is ostensibly about fractions. And the people who jumped in the conversation work with elementary teachers, they work with high school teachers, they're talking about their different experiences of fractions. And then a math education researcher joins the conversation. And the first person to reply to the researcher is a classroom middle school teacher. We all only get 140 characters, no matter who you are, how many degrees you have, and the conversation is really richer because of that. So you should be on Twitter, and here's how you start. You start by lurking. And it's okay, it's not creepy, it's not stalking. And you don't have to read every tweet, just like you don't have to read every bullet on that slide. It's okay to just dip in when you can. When you're ready, you're going to start talking to people. The way to do that, in my opinion, the way I started, is to converse with individual people. Somebody asks a question, and then you click the reply button right under their tweet, and it automatically puts the their Twitter handle, and they get a notification that you're talking to them. Then you get to know people, and you realize you have something to say that they might be able to help you out with. That first tweet didn't have any people's names in it. Nobody really saw it, nobody wrote back. So then I was like, wait, I know some calculus teachers. I put their Twitter handle. They read my tweet. You also saw in that first tweet there was a hashtag, like the number sign, and then a thing. That's a word on Twitter that you use to organize tweets about the same idea. So those are just some of the hashtags that math teachers use to find each other. So when you go on Twitter, you can search for a hashtag. The other thing hashtags do is they organize tweets in time. So there are times when people say, we will all be on the internet together, tweeting and using the same hashtag in our tweets, and it becomes a live chat. The elementary teachers, the middle school teachers, and the special ed teachers have these really vibrant chat communities. They've happened for years. That's what Students with Disabilities Math Chat looked like this week. There's a lot of nuance and a lot you can get out of 140 characters when you're all on Twitter at the same time using the same hashtag to organize your tweets. So if you haven't already, now is the time to get on Twitter. Here's how you do it. You go onto twitter.com and it says, let's make an account, and it says, hey, I bet you want to follow Jamie Foxx. And you say, no, I want to follow math teachers. So go watch the video of this talk, find people in here and follow them. Then it'll say, upload an image. Do not skip this step. What we say is, don't be an egg. That's the default image is an egg. People will think you're a spammer or a robot if your picture is just an egg. So it doesn't have to be your face, but it should be a real picture. Also, put something in your bio. Don't spend a lot of time making this creative. Just write like, I'm a math teacher, or high school math teacher, because then the people you want to talk to will find you, and they'll follow you if you tweet at them, because they'll say, oh, they're a math teacher. So, to review, it's okay to lurk. You don't have to read every tweet. Use reply or the @ sign to converse. Use hashtags to organize around one idea, and fill out the bio and be sure to upload a picture. Once you've done those simple steps, you're a twittering person, a tweet, whatever you are, you're a member of this amazing community of really caring educators who love to share their ideas and share with each other. We love Twitter and the people we meet there so much. We actually get together in real life. I know some people whose children are feared for them. They're like, you're gonna hang out with people you met on the internet? But it's true. TwitterMathCamp.com. Like 4 years ago. It goes on for verses and verses about how amazing it is. So, yeah.
Thank you, Max. And I think we leave bigger and stronger than we were when we came in. How about another round of applause for all of them? And thanks again to April and the board and all of you. Have a good rest of your conference.